technology. Thank you so much. You are here, and please make your presentation.
Well, yes, thank you very much for that nice introduction. Yeah, so I'm Kathy Malone, and we're going to be talking about how we're using design-based research in the development of a curriculum that will hopefully answer several of the issues that were brought up in previous presentation. So I'm not going to actually be making the presentation. Golfarita is going to be making the presentation, and she is our project manager and one of our research assistants. So Golfarita.
Okay, thank you a lot. Can you hear me well?
Yes.
Yes. Good day, dear colleagues. My name is Golfarita Murzakulova, and I'm speaking from Kazakhstan, Nazarbayev University. As my professor mentioned, we are going to present the topic, the role of design-based research in the development of primary level integrated STEAM curriculum in Kazakhstan. In my presentation, I will focus on background information, then present research purpose and research questions, and explain methodology briefly, and discuss literature review and explaining what is design-based research and dramatic inquiry, and demonstrate some of our activities that we are prepared for our project, and lastly, discuss the results that we are expecting. Worldwide, there is a decline in the number of students pursuing engineering or science career. For example, according to the Organization for Economic Cooperation and Development 2014, only 15% of students are awarded engineering degrees, while 32% of students are awarded social studies degrees. It means that there will be a shortfall in the future of engineers in the future for highly technical tasks. And also the same organization reported that there is a large gender gap, with less than 25% of degrees of engineering and science degrees are completed by females. Also PISA results demonstrate that Kazakhstani 4th and 8th grade students have also difficulty using science knowledge and using their science skills and presenting, analyzing scientific data and giving scientific conclusion, valid conclusion. All these statistics tell that we should implement innovative program that stress authentic practice in STEM skills. And why STEAM? As you know what is STEAM: science, technology, engineering, art, and M. Why with A? Why STEAM? Researchers found that integrating arts into STEAM positively impact on students' proficiency in not only their science, but also their reading and writing. On the other hand, it increased students' engagement. Graham and Burley 2016 claimed that it improves students' understanding of science concepts and their engagement. And the last one, which I would like to accentuate, is according to Warner and Anderson and 2004 and McGregor 2017, using dramatic inquiry approach to teach science subjects in the classroom allowed students to understand scientific concepts better because they were more engaged in science dialogues, and also students felt more enthusiastic. So they are accentuating dramatic inquiry. And therefore, our team decided to study, to pose the following research purpose. So we have two main research purposes. It is to examine the effect of incorporation of dramatic inquiry into STEM units on students' conceptual understanding of engineering, technology, and science. And the next goal is to determine the effect of the I-STEAM units on students' engagement, engineering identity, competence, motivation about STEM topics, and career. In order to get the purpose, we put the following research questions. It is, how does the incorporation of art in STEM units impact primary students' conceptual understanding in STEM topic? How does the incorporation of art in STEM units impact students' interest, engagement, motivation, identity, self-efficacy in engineering? And how does the incorporation of the arts in STEM units impact students' engineering identity in primary classrooms? This project is a mixed method case comparison approach using design-based approach, and we are planning to do pre and post-student assessment about engineering, technology, and science, and also we will do classroom observations, pre, post-student, and teacher interviews. As I mentioned, we are using design-based research, and as you know, design-based research in short is designing activities, designing curriculum, then testing and implementing it. And we designed our tasks, our units according to these main phases of design-based approach. It is analysis of problems with researchers and practitioners, development of outline of initial curriculum based on research, iterative cycles of testing and refinement, and reflection to produce enhanced practices. And according to these four main phases of design-based approach, we prepared STEM and the STEAM units, which consist of activities about technology, science, and engineering. The unit is for third grade students, and we are going to use these units for students who study in mainstream schools in Astana, in Nur-Sultan city of Kazakhstan. But before implementing I-STEM and I-STEAM units, according to the phases of design-based approach, we are going to brief teaching trial phase, and also after this phase, I-STEAM unit and I-STEM unit will be implemented. Will be implemented in two different schools, mainstream schools of Nur-Sultan. But before implementation, we definitely do revision. Students also during this unit. The main goal of this unit, in this unit of students, is to design a windmill. As you know, in Kazakhstan, especially in Astana, there is a lot of wind, and students are asked to prepare a windmill. And before doing windmill, they do different tasks about technology, science, and engineering. And during these tasks, they will behave themselves as real experts, as professional scientists, professional technicians, professional engineers. And this is dramatic inquiry approach. In dramatic inquiry approach is also known as a mantle of expert. The originator is Dorothy Heathcote. And according to this approach, students were mantle of experts. They feel themselves as experts, professional engineers, professional scientists in the classroom. So while they do activities, they do what these professionals do. They communicate like real experts, and they solve problems like real experts, and this is called dramatic inquiry. And since they do what expert engineers, what expert scientists do, it allows them to deeper understand these scientific concepts. students in the unit they will use also badges, but it is called science. In order to help them to easily feel themselves as experts, there is two elements of dramatic inquiry, which is called cognition and science. And if I talk about science, if you see on this picture, on the books, there is a sign, and this is an emblem of imaginary Kazakhstani Engineering Agency's emblem, and they imagine themselves that they are real members of this agency, and they wear badges of these agencies, and these badges help them to feel that they're real scientists, real engineers. And when they put on, they feel they behave themselves as experts, imaginary experts. But when they take it out, they can turn back, go back to their real position, students, and ask as students from teacher what is not clear. And the head of the organization, imaginary organization, can write an email or can write, can come to the class and explain that their task is to design a windmill, which is needed in Nur-Sultan city. Yeah? And here we give one example of our unit, and it is called technology in a bag. As I mentioned before, doing a windmill, they do different tasks, activities, and in this activity, students are presented a bag, and inside of this bag there are different types of technologies. It is single object technology, for example, paperclip, objects that are made of system of multiple pieces of technology, for example, Kazakh head kulakshın, if you know it, and technological processes such as, for example, doing commerce, doing court, and so on. And they closing their eyes, they should guess what technology is it, and after that they should discuss what is the technology used for, what is made of, and other materials it could be made from. And then the whole class develop a group consensus for the definition of technology. For example, they might develop such kind of definition for technology. Technology can be an object, system of objects, or a process that solves a problem and are produced by engineers. How we also incorporated arts into our project, into our unit, is we also developed a storybook which is called Kazakh Course Engineers. And in this book, the book explains students who are engineers and what they do. For example, if you pay attention to this dialogue, it is the dialogue of white and the brown horse. The white horse asks, do engineers construct trees? Brown horse says, are you sure? And the white horse says, no, but Kazakh engineers use trees to design shelters such as yurt. And you see this yurt, it is a technology, and it's the product of engineers. So this way we are going to explain what engineers do and what are technologies. What are our expected results? We are expecting that students will develop an engineering identity as shown through dialogue with the inclusion of dramatic inquiry. They increase their knowledge of science concepts, engineering, and technology. And we are expecting that there will be increased interest in technology and STEM careers. And also we are expecting students in the I-STEAM unit to perform better on all these measures than the STEM group. Okay, nazarlarınızga rahmet. Thank you for your attention. If you have any questions, please feel free to ask.
Thank you so much for your presentation. I will ask the audience if they have any question. Any question to Golfrida? Actually, I can ask you that how students you plan that they will design the windmills? Do they make in a software, in a computer, with a paint program, or with their hand? Do you expect to have a hand-on activity, or how do you plan this activity? Just from technical reason, I'm curious, how do you expect to do this?
Mm-hmm. It is. They're not going to. They are designing a windmill with the help of hand-on materials. We're going to. We are going to bring them materials such as plastic, papers, plastics or cartons, and other styrofoam materials from plastic, and maybe some wood. And they should think how to design a windmill with these materials.
Mm-hmm. I think that this is a key question. All the time when students have something in their hands, they are much more motivated if they can do themselves. I like very much this idea. And therefore I ask you, do you plan to extend this activity in the whole country or only in some region of the country?
Of course, I want to extend this project to the whole Kazakhstan, because windmill is a real needed thing in Kazakhstan. As I mentioned before, there is a lot of wind in Kazakhstan, and if it's not wind, they might produce a different thing. For example, I don't know, something for agriculture. But I think this is the effective way to explain students what is engineering, science, and technology.
Thank you. Anybody else would like to ask you? We have some minutes, 3 more minutes. Katie, if you want to make some remarks.
Oh, well, Gofri did a fantastic job, I think, but the idea of the use of dramatic inquiry, especially at that age level, is to allow the students to really, and it goes back to the question that was asked earlier about why do this at this elementary level, because this is where the kids can really get an identity for being engineers. Like, oh, I really want to be an engineer. I really want to be a scientist. And the dramatic inquiry really allows them to we hope, really start becoming or thinking of themselves as engineers. So hopefully their dialogue changes and how they talk about it versus just having a project that's a windmill. In the dramatic inquiry, they're given a commission to make a windmill that will power a museum for the future. So in this case, hopefully that dialogue will get that self-identity. So we're hoping through videotaping of student discussions that we'll actually see those differences between the STEM group and the STEAM group. But then we have to track. We have to track them all the way through college to see if they actually end up by being engineers. Of course, that's a totally different study. But thank you.
Thank you so much. I suggest to ask questions after the session online via chat and keep in contact. Let's move to the last presenter of this